rules of finding integrating factor. So for rule number first, if mx, it is not m dx, m into x plus n into y is not equal to 0, then the given equation is, and the given differential equation is homogeneous, then 1 by mx plus ny is integrating factor of the that differential equation. Okay, so this is the first rule, that is the given differential equation is homogeneous differential equation. So we know that when the given differential equation is a homogeneous differential equation, if m and n both are homogeneous functions of same degree, we know that how we can identify the homogeneous differential equation. So this type rule is applicable to homogeneous differential equation. So if the given differential equation is homogeneous and mx plus ny is not equal to 0, then 1 by mx plus ny is the integrating factor of the differential equation, that differential equation. So this rule gives the another method to obtain the solution of homogeneous differential equation. One method for homogeneous equation is already we have seen in the previous topic, that is homogeneous differential equation. That is how we can solve the homogeneous differential equation and how we can identify that the given differential equation is homogeneous differential equation. So we have already seen in the previous lectures how we can solve the homogeneous differential equation, that is by substituting y by x is equal to v in the, we can solve the homogeneous differential equation. But in this topic, in this rule, we will solve the homogeneous differential equation by some another method, that is by reducing the homogeneous differential equation to uh, exact differential equation. So how we can reduce the homogeneous differential equation to exact differential equation? If we multiply by 1 by mx plus ny as an integrating factor to that homogeneous differential equation, then the differential equation becomes a, the differential equation becomes a exact differential equation, then we can find the solution. So we have the two methods to solve the homogeneous differential equation. Already we have seen one method in the previous topic, how we can solve the homogeneous differential equation. So if we observe the problem in exam of homogeneous type, then we can solve the problem in two methods, by using two methods. So but if the instruction, that if the problem is of the type homogeneous differential equation, but the instruction is that, suppose the question is of that type, that find integrating factor and solve, then we have to apply this method, this rule, that is 1 by mx plus ny as a integrating factor. So find mx plus ny, it is not equal to 0, then 1 by mx plus ny is the integrating factor, and then multiply the given equation by 1 by mx plus ny, then given differential equation becomes exact differential equation, and then find its solution by using the rule, integration m dx plus terms in n independent of x dy is equal to constant. Okay, so when mx plus ny is 0, then 1 m by n is minus y by x, m by n is minus y by x, because when this mx plus ny is 0, then m and n are same but different in the sign. Okay, we have m by n as minus y by x. So suppose this is equal to 0, then what happened, m by n, so solve this equation. So we have m by n is equal to minus y by x, then the differential equation m dx plus n dy is equal to 0 is written in the form dy by dx is equal to minus m by n, that is shift this minus mx and then shift the dx to LHS and m to RHS. So we have minus m by n dy by dx is minus m by n, and so substitute this minus m by n as y by x. So we have, and then dy by y is equal to dx by x, that is in the variable separable form, and then integrating. So we have log y is equal to log x, 1 by y integration is log y, 1 by x as the integration log x. So we know that how we can solve the variable separable differential equation. That is the first type, that is separate the variables and integrating both sides. So we have 1 by y as log y is equal to 1 by x integration is log x plus constant of integration, suppose c1, or log c at the constant log c. So log y by x, log y minus log x is log y by x, is equal to log c as new constant, and then cancel log of both sides. So y by x is equal to c, or we can write y by x is equal to e raised to c1, and then e raised to c1 as new constant. So y is equal to cx is the where k is plus minus c, okay, which is the general solution of m dx plus n dy is equal to 0. So if mx plus ny is not equal to 0, then 1 by mx plus ny is its integrating factor of that homogeneous differential equation. But if mx plus ny is 0, then we have the very simple method. By simple method, we have the solution of that homogeneous differential equation. That is y is equal to cx is the solution of that differential equation. So this rule gives the methods, second method, alternative method to obtain the solution of homogeneous differential equation by finding integrating factor. So just find mx plus ny, which is not equal to 0. Then we apply this method, okay? And if mx plus ny is equal to 0, then we have the solution by using variable separable method. So this rule gives the second method, alternative method to obtain the solution of homogeneous differential equation. So next is mx plus ny is not equal to 0. Similar to this, mx plus ny is not there, mx minus ny is there, mx minus ny is not equal to 0, and the differential equation m dx plus n dy is equal to 0 has the form, it is of the form f1 xy. What is f1 xy? F1 xy means the function of x into y dx plus f2 xy. F2 xy is the another function of x into y. X dy is equal to 0. Then 1 by mx minus ny is integrating factor of that equation. So we will discuss this rule when it is applicable for the example. So if the example is of this type, f1 x into y, that is some function of x into y, into y dx, then plus some function of x into y into x dy is equal to 0, then 1 by mx minus ny is integrating factor of that differential equation. So if the problem is of this type, then we have to apply this second rule. Not mx minus ny is 0. Suppose if the problem is of this type, but mx minus ny is 0, then again we have m by n is y by x, m by n is y by x from this, like this. Here m by n is x, y minus y by x. Here we have m by n as y by x, and then m dx plus n dy. M dx plus n dy is what? M dx plus n dy is dy by dx is equal to minus m by n, and substitute m by n as y by x. So we have dy by dx is equal to minus y by x. That is dx by x plus dy by y is equal to 0. And then x 1 by x means log x, 1 by y means log y. Its integration is equal to log c, and so log x plus log y is x into y. Log x into log x into y is equal to log c, means x into y is equal to c is the solution. So which is the general solution of this equation if mx minus ny is 0. So if mx minus ny, if we check mx minus ny, it is not equal to 0, then 1 by mx minus ny is its integrating factor. Then we multiply by 1 by mx minus ny to that differential equation and find the general solution of that differential equation. Or if mx minus ny is 0, then we have x into y is equal to constant is its solution. Then the rule third, if dA by m by dA by y minus dA by n by dA by x divided by n is function of x alone, that is it is free from this value of this quantity is free from y, is function of x alone, means it is not function of x and y, it is the purely function of x. There is no y in this quantity. Say fx, we can say it is equal to the value of this quantity is equal to fx, or constant. We have the value of this dA by m by dA by y minus dA by n by dA by x divided by n as constant term or function of x alone. Then we say the integrating factor is e raised to fx dx or e raised to c dx. That c is the, and this is the integrating factor for this such a type of example, m dx plus n dy is equal to 0. So find dA by m by dA by y, dA by n by dA by x, and that subtraction divided by n is function of x alone. Then e raised to integration fx, it is either c constant or function of x alone, it is not involve contain y. Then we apply this rule. And if dA by n by dA by x, remember this m and n, the derivative is with respect to x and with respect to y. It is not dA by n by dA by y. The term is what? Just dab n by dab x first, then dab m by dab y second, divide by m. Divide by m is a function of y alone, that is fy. What is m? M is divided by m. M is the coefficient of dx, and e divided by m, then function of y alone. Divided by n, then function of x alone. Okay. So dab n by dab x minus dab m by dab y divided by m is a function of y alone, say fy, or is a constant quantity. It's either function of x, y alone. It is not the function of x. Then integrating factor is e raised to integration fy dy, or e raised to integration c dy, if the value of this quantity is constant c of the equation m dx plus n dy is equal to 0. So these two rules are comparatively same, but in the case of this first, divide by n is function of x alone, and here divide by m is the function of y alone. So if this happen, that if this quantity is function of y alone, or this quantity is function of x alone, then e raised to integration fx or e raised to integration fy dy is the integrating factor. And the rule number 5, if the equation is of this form, x raised to a, y raised to b, in bracket my dx plus nx dy plus x raised to c, y raised to d, where a, b, c, d are constants. A, b, c, d, p, q, r, m, n, all are constants. M, n, and this p, q, all are constants. Then x raised to alpha into y raised to beta is an integrating factor. What is where alpha and beta are so determined that when the equation is multiplied by x raised to alpha, y raised to alpha, the resultant equation is exact. That is, this alpha and the beta are depend on the problem. That is why to take this alpha and beta as two numbers, and that depends on that problem. So that is, first the differential equation is of this type. Then x raised to alpha, y raised to beta is its integrating factor with the appropriate choice of this alpha and beta. That is depend on that example. That is, we take alpha and beta as two numbers in such a way that if we multiply by x raised to alpha into y raised to beta, then the resulting equation is exact. So these are the 5 rules and the basic method, inspection method. So in all there are 6 methods. So we will see the mixed problem of depend on these 3 methods. So first problem, solve x square y minus 2xy square dx minus x cube minus 3x square y dy is equal to 0. So the given differential equation is, compare with m dx plus n dy is equal to 0. So the question is solve, or another question is find integrating factor and hence solve. What is the question? Find the integrating factor for this differential equation and then solve. So the given equation is m dx plus n dy of this form. Then m is this x square y minus 2xy square. n is x cube minus sign in bracket x cube minus 3x square y. So dab m by dab y. Dab m by dab y means the derivative of m with respect to y, means x is constant, x square is constant, derivative of y is 1, minus 2x is constant, derivative of y square is 2y. So 2y and minus 2x become minus 4xy. Then dab n by dab x minus x cube. The first term is minus x cube. Its derivative, or take minus sign as it is, or the derivative of this quantity is in bracket 3x cube x square. Derivative of x cube with respect to x minus 3y is constant. Derivative of x square is 2x. So in all become minus 6xy. And if we apply the negative sign on this, we have minus 3x square plus 6xy. But these two are not equal. Dab m by dab y is not equal to dab n by dab x, and therefore the given equation is not exact differential equation. This given differential equation number 1 is not exact differential equation. But we observe that m and n are homogeneous functions of x and y of same degree. This is this homogeneous function. This is a homogeneous function of degree 3. So both m and n are homogeneous functions of degree 3 in x and y, and therefore the given differential equation 1 is a homogeneous differential equation. So the given differential equation is a homogeneous differential equation, but it is not exact differential equation. And that is we have to apply the first rule, that mx plus ny. Now we have to find the value of mx plus ny. Now what is mx plus ny? So mx plus ny is x square into y square. So find mx plus ny. Mx, m into x plus n into y. So multiply this mx m with x and n with y, and add, we have the answer x square y square, that is x square into y square, and it is not equal to 0. So this is the example of the rule first, that is mx plus ny is not equal to 0, and the given differential equation is a homogeneous differential equation, because m and n are homogeneous functions of same degree. M is a homogeneous function of degree 3, n is also a homogeneous function of degree 3. So we know that what is the definition of homogeneous function. The function is called homogeneous function if in each term the addition of powers of x and y are same. So if you observe the first term, the addition of power of x and y is 3, 2 plus 1. Power of x is 2, power of y is 1, so 2 plus 1 is 3. In the second term, the power of x is 1, power of y is 2, so 1 plus 2, 3. So there are two terms in m, and both the terms has the addition of powers of x and y is 3. So this is the homogeneous function of degree. Similarly, if you observe this minus x cube is the power of x is 3, y power of y 0. So 3 plus 0 is 3, and the power of x is 2, power of y is 1. So 2 plus 1 is 3. So both m and n are homogeneous functions of degree 3. And so this given differential equation is a homogeneous differential equation, and mx plus ny is not equal to 0. And therefore 1 by mx plus ny is integrating factor. So we will find 1 by mx plus ny. So its integrating factor is 1 by mx plus ny. So integrating factor is 1 by mx plus ny. So find mx plus ny. So write what is mx? X cube y minus 2x square y square. And what is plus ny is what? Minus x cube y minus plus 3x square y square. So we have the answer minus x square y and minus x cube y and minus x cube y get cancelled, and minus 2x square y square and plus 3x square y square become x square y square. So this is the value of mx plus ny is x square y square, and so integrating factor is 1 by mx plus ny, that is 1 by x square plus x square into y square, and this is the integrating factor. So the question is solve this example, solve this differential equation, or the another format of the question is what? Find integrating factor for this differential equation and then solve the differential equation. So this is the another. And for MCQ type questions, the question is we are given this is the differential equation, and question MCQ type question is what? Which of the following is integrating factor for this differential equation? So we identify that this differential equation is homogeneous, and now 1 by mx plus ny is its integrating factor, that is 1 by x square into y square is integrating factor. So the question of type MCQ is find integrating factor, or which of the following is integrating factor. So the given differential equation is this, and the answers for the multiple choice questions, multiple choice are given, that is suppose 1 by x square into y square, 1 by x square plus y square, x square into y square, and 1 by x into y. So the correct answer is what? Integrating factor is not x square into y square. What is the integrating factor? mx plus ny is not integrating factor. 1 by mx plus ny is integrating factor. 1 by x square into y square is the integrating factor. X square into y square is not integrating factor. So multiplying the given differential, now we have to solve the so we have to find the solution of this differential equation number 1. So multiplying by 1 by x square into y square, we get equation 1. Multiply to equation 1 by x square, 1 by x square into y square. So we have x square y divided by x square into y square is 1 by y, minus 2x y square divided by x square into y square is 1 by x. So 1 by y minus 2 by x dx minus x cube divided by x square into y square is x by y, x by 3 by y plus 3 by y. This quantity minus become plus 3x square y divided by x square y square is 3 by y plus side minus x cube divided by x square into y square is x by y square. So here is plus sign. So this after effect of negative sign, this become plus and this term become minus. So dividing by multiplying by 1 by x square into y square. So we have this to equation 1, we have this, and this is exact differential equation. Now this equation becomes exact differential equation. No need to verify this is the exact differential equation or not exact differential equation. For interest, we can check whether derivative of this quantity dA by m, this now this is m, so we check the dA by m by dA by y, and we check this is now n, so dA by n by dA by x both are same. So if you find dA by m by dA by y, then 1 by y derivative is minus 1 by y square, and derivative of minus 2 by x is 0. So dA by m by dA by y is minus 1 by y square. And what is dA by n by dA by x? 3 by y derivative is 0 minus x by y square. So 1 by y square is constant and derivative of x is 1. So we have the answer dA by n by dA by x is 1 minus 1 by y square. So we have dA by m by dA by y is equal to dA by n by dA by x. But no need to check whether this equation is exact differential equation. Once we find the integrating factor and once we multiply the given differential equation by this integrating factor, then the resulting equation is what? Is the exact differential equation. This now resulting equation, after multiplying the given differential equation by the integrating factor, we get the exact differential equation, which is an exact differential equation, and hence its general solution. Now we have to find its general solution. So what is the formula? Integration m dx, keep y as constant. So no need to write this y as constant. Write just integration formula. Write first formula. Integration m dx plus terms in n, integration terms in n independent of x dy is equal to constant. So m is 1 by y minus 2 by x dx plus integration terms in n independent of x. So there are two terms, 3 by y and another term is minus x by y square. But this 3 by y is independent of x, so take that 3 by y. But minus x square by y square is the term depend on x, so don't take that term, delete that term. So we have the terms in n, this is n, and the terms in n independent of x is 3 by y. So 3 by y dy is equal to c, is the constant of integration. So treat y as constant. Now we have to integrate this with respect to x and treat y as constant. While integrating this factor with respect to x, treat y as a constant function. Okay, constant number. Then what is 1 by y? 1 by y is constant, and so integration of 1 by y is what? Integration of any constant is what? Constant into variable. So 1 by y integration is 1 by y into x, because x is variable, and 2 as constant, and 1 by x integration is log x by using the rule, plus 3 is constant, and integration of 1 by y with respect to y is log y is equal to c. And so this is the final answer, or we can write it as 2 log x means log x square minus log x square by using rule. Log a raised to m is m log a. So m log a is log a raised to m, log x square. And then log 3 log y is log y cube. And so log y cube minus log x square is log y cube by x square by using rule. Log a minus log b is log a by b. So we have this as the final answer, or no need to write this step, write this as the final answer. So this is the general solution of the given differential equation, this differential equation. So we can also solve this problem. This is homogeneous differential equation. So we can solve this problem by using the method which is applicable to homogeneous differential equation, that is substitute y by x is equal to v, or y is equal to vx. So we can also solve this problem by using the previous method which is applicable to homogeneous differential equation. So we will solve this problem in two methods. But if the question is solved, then we apply either homogeneous type method or this method, that is the reduce the equation to exact differential equation and then solve the find its answer. So it's depend on you. We have to apply either homogeneous type method or this method, that is by reducing the method differential equation to homogeneous. But if the question is of the type find integrating factor and then solve, then we have to apply this method, That is, we have to apply, we have to find first integrating factor and then we have to find the solution. So the question is, sometimes the question is just find integrating factor of this differential equation. So this 1 by x square into y square is the integrating factor. So this is the example on the exam, rule number 1. So we will see the examples of rule number 2, rule number 3, rule number 4 and rule number 5 in the next lecture.